Oh, sorry, I'm a teeny bit late. I need to go take care of something. How you guys doing? Can you guys hear me okay? For those of you that are here,
Yes.
good, great, thank you. Let me open the chat window here. So, welcome to MIS 4397, the Open Systems class. I'm going to go ahead and start. I'm going to record and post all of these sessions on YouTube. Although I still highly recommend that you participate synchronously when you can. I'm going to have classes from 4 to 6 p.m. just like in the syllabus for this class during that time for those of you that can attend. And like I said, I'll post them on YouTube. With the exception of Fridays, what we're going to basically do for the class is Monday through Thursday, 4 to 6, I'll have a Zoom class meeting. On Friday, I may have a Zoom meeting, but it's going to mostly be question and answer time. And you can optionally attend that. And I may only have a few people participate, if at all, but that might be the time for you to ask questions and while you're doing the assignments. And usually I'm going to make the assignments that are due. This used to not be an assignment-based class, but because of COVID-19 and the fact that I can't really closely monitor people, everything's going to have to be, it's project-based, but there's going to be milestones that you have to reach. So you'll have to turn in a Blackboard assignment, more of a questionnaire, at the end of each week to let me know where you're at and where your team is at. And yes, we are going to still participate in this class with teams. You'll just communicate with each other using email, you can use Zoom with each other if you want to use Microsoft Teams or whatever else you want to use to communicate with each other. I don't care how you do that. I recommend that you use Zoom if you've got a Zoom account to do that. But this class, and I don't know, has anybody in here taken this class before or tried to, or have you heard anything about it before? And here's what I like, by the way, is if you've got a video camera and you don't mind me seeing you on video, I'd like you to turn your video on. It gives me some feedback so I know that you're there, and so I can see what you look like, and I get more of a feel of a participation. Turn your audio on if you want to talk. That's fine too. Or type in the chat window. I don't always see the chat window, especially if I'm sharing a screen, but I'll eventually see it. So nobody wants to share their video. Okay, that's all right. When you're coming into Zoom, let's just talk a little bit about housekeeping for the rest of the semester in terms of using Zoom. I'm going to use Zoom. Hello, Hoa. Is that how you pronounce your name, Hoa? Is that close enough? Robert, is that how you pronounce your name? Okay, just being silly, okay. Housekeeping wise, I'm going to use Zoom. I considered using Microsoft Teams. I took a survey before. Turns out Zoom maybe, although Zoom has issues, turns out that Zoom is a preferred tool to use. So that's what we're going to use is Zoom. Your grading, like I said, is going to be based on the projects and you're going to turn in basically assignments at the end of this week, each week. So participation, although I usually say this in my PowerPoints, participation being a major part of your grade, it's going to be difficult to grade you, like I said, on participation. But you can help me, like I said, by turning on your video if you have video, actually using your audio and asking questions, or using the chat window and typing in your question or questions in the chat window, because that gives the rest of the class the benefit of hearing your opinion or seeing the answer to the question. Or sometimes people are just afraid or not sure how to ask a particular question, and somebody else comes up with that question and asks it properly. Sometimes it's difficult to ask a question properly to get the right answer. I oftentimes give the wrong answers, but it was because it was the wrong question, if you know what I mean. I didn't hear the question right, or it wasn't formulated right. I try. And you'll find a lot of times to some of these questions, I'm going to say, I don't know. Maybe we should Google that. Okay, so a little bit of a little more housekeeping. I'm going to try to use screen sharing most of the time, so it's not just my head talking to you. I got some PowerPoints that are prepared, but most of the time what we're going to be doing is remote viewing servers that I've already set up for you guys to use. You're going to be using servers and virtual machines which exist in the EI lab, which is room 122 of Melcher Hall, but you're not going to be able to get physical access this summer. Everything is being taught remotely, and I hope you guys are okay with that. We have no choice. I happen to actually be here today at U of H, but I'm not always going to be here either. Just dealing with I've got some physical stuff that I'm taking care of today, so I needed to be here. Hang on one sec for me. I just need to make sure this is not super. Important. Okay, so some of you are in my 4477 class also. I believe I recognize a couple of the names. So you're taking both of my classes this summer. You're going to see more of me than you want to, probably, or hear more of me than you want to. Some of you, how many of you already know me? Anybody know me? Not that I'm looking for fame or whatever, I'm just saying. So yeah, Jessica, so I've had you in a class before, right, Jessica? Name sounds familiar. And then
yes, I was in your last semester class.
Okay, in the 4477 class.
Yes.
Yeah, that ended up being challenging due to COVID-19. It's a little less challenging, but this is going to be a very challenging class to do in the summer. This is not going to be an easy class, especially given COVID-19, but you're going to learn a lot. You're going to learn a whole lot because of the fact that we're having to do everything remotely. So you guys are going to become remote access usage specialists or experts here by the end of this semester. I'm not just talking about being a user, I'm talking about being an administrator of this stuff. So 4397 class. MIS, let's see if I finish the housekeeping. So we're not going to have a synchronous class on Friday, but I will occasionally, not every Friday, but begin a Zoom meeting. It's going to be the same code every time. Okay, so my code, the 409-331-5253 code happens to also be my Google telephone number. So you guys can always contact me. First of all, attempt to contact me at jake@uh.edu. Can you guys see that in the chat window that I'm typing? jake@uh.edu, that's the best way to contact me. Now you might get email back from profjake@gmail.com because the jake@uh.edu is really just an alias. That's how we do everything here at U of H. So we're going to have we're going to officially have a synchronous class Monday through Thursday. Try to attend, like I said, if you can, synchronously. But if you cannot, like I said, I try to, excuse me, I'm going to try to get these things posted every evening after we have the class onto YouTube. You can find me pretty easily on YouTube by just simply searching for Prof. Jake on YouTube or searching for MIS 4397. There's a channel called MIS 4397, which will be the channel for this class. If you were to go there now, you will see stuff from the previous semester, which, you know, it's interesting to look at, but it won't mean as much to you. I usually show, I tell you what, I'll show you a little bit of a PowerPoint presentation from the 4477 class, just to give you a little bit of intro about me, just so you know where I'm coming from. Okay, not trying to brag or anything, just so that you know what kind of questions you can ask me and why I teach this class. I invented this class, so I think this is a good class to take. I think it should be mandatory, mostly because the whole world is Linux. And if you didn't figure that out, this class is pretty much a Linux-based class. Open systems, not necessarily Linux, but that's the best example of an open system. So let me share a screen here. Can you guys see the screen I'm sharing now or not? Oh, wait a minute, I gotta click that. Now I'm sharing a screen. Should be nothing on it yet. I will put something on it in a minute. As I told my previous class, I'm going to teach you guys about best practices in terms of using Zoom meetings, among other things. And one of the things that you never want to do is log into a web page like your Access UH web page while other people are seeing you log in, because some of you have probably done something similar to what I've done, like you type in your password in the name field and expose it to everybody. So I always do it off. I always do a meeting. Excuse me. I launch a meeting. See, I'm going to take my. Where is it? I'm trying to do that. So I'm going to take this and drag it over to my other window that you can't see. Log in over here on accessuh.edu, and then I will bring it back over. That way, in case I do a boneheaded thing like type in my password, you don't see it. Otherwise, then I have to change it. Give me a second. I'm moving a few things around. How many of you have used anything other than Zoom for meetings? Like Microsoft Teams or Skype? Okay, some of you have used Skype. In your opinions, if you want to share, what do you like better? Skype, Zoom, Microsoft Teams? So there's the 4397. I make extensive use of Blackboard, by the way. So Teams, do you like Teams more than Zoom? So it was interesting in that the previous class, the 4477 class that I teach, liked Zoom better than Teams. That Zoom does a whole lot more. I don't know if that's really true or not. I have not used Microsoft Teams, so I can't speak authoritatively. I'm a programmer. I've been a programmer, not so much a programmer anymore, but there are things I would do differently in Teams. You're indifferent. Well, good. I'm glad you're indifferent. That's probably the way that most people should be with respect to these applications. You should just use the application that tends to work best for the job. You know, I hear these arguments, and this kind of goes hand in hand with this class. I hear people talk about, well, iPhone is better than Android, or Apple is better than Microsoft, or Linux is better than all of them. They're all tools. They're all different tools to do different things, and you should use the appropriate tool for the job. That's why we have a lot of different types of screwdrivers in our toolbox, a lot of different tools in our toolbox. Microsoft, one negative, actually there's a lot of negatives, but one of the biggest negatives for Microsoft is they try to be everything to everybody. They try to be that toolbox, and they have all the tools, but they're more like an all-in-one tool. The all-in-one tools they might do everything, but they don't do everything very well. So I'm a firm believer of using the appropriate tool. So anyway, let's just talk about some other items. And if you want to ask a question, by the way, there is a way to, let's see, you can raise your hand. Is everybody muted, by the way? Let's see, yeah, you're muted, but you don't have to be if you don't want to be. Let's see. I know there's a way you can virtually raise your hand if you want, but if you have a question, just turn on your mic and blurt it out, or type it in the chat window. Eventually, I should see it. Let me take a look at the content. So I will try to post before each class a new announcement. So this is a static announcement that's sitting at the top of this page that I altered. And I apologize if you got it 2 or 3 times, but I kept adding information to it. Any new, and these are all old, I need to get rid of a lot of these older ones from the previous semester. I'll just begin deleting those. Any newer announcements will appear on this page. So what you should be doing is logging into Blackboard every day, coming to the announcements page first, see what the latest announcement is, which you should get in email as well. But I would also check here in case I made a supplemental announcement that did not get emailed out. I don't email out every single announcement. Underneath course content, there's a syllabus, which I haven't updated in a little while, but most of it's pretty much the same thing in terms of what we're actually working on under course content here. And I know that I need to lay this out a little bit better, but you'll see that I refer to Linux a lot, the Linux operating system. This is called the Open Systems class, but it really is called the LAMP class. Can you guys all see my screen that I'm sharing okay? By the way, I need to double check. Can all see it? Okay. Let me open a little Word document here, or WordPad, so I can type in some words. So I'll share that at the same time. So Dr. Parks likes to call this the LAMP class. Okay. First of all, does anybody else have any other questions on housekeeping or the general way that I'm going to teach the class this semester? We're meeting Monday through Thursday synchronously, optionally on Friday. Assignments will be due at the end of each week, either Friday at midnight, or I might be generous and say Sunday at midnight, but I'd like the weekend to grade them. So if you do have any other questions, because I know I'm leaving a few things out, send me an email. jake@uh.edu is the most popular way to get to me. But if I'm not being very responsive, as I mentioned, use the Google number 409-331-5253. Text it first. You can text it. If I don't respond to a text in a timely manner that you feel is timely, call it. It should ring on my cell phone. Try to avoid doing that unless it's a real significant emergency. But please communicate with me. That's the way you're going to do well in this class. I'll just skip to that right now. The way that you do well in this class is you try and you communicate and you show me that you are engaged. I had students in the previous class, the previous semester, that believed they weren't doing very well because they were trying. And some of this class is going to be very technical. Some of it's going to be very new to you if you've never done any coding before. And we're not going to do a lot of coding. Parks wants me to teach a lot of coding, but I don't teach coding. I teach what most of us need to know how to do, and that's configuring. In other words, gosh, I can't spell today, configuring. In other words, I'm going to teach you how to find a tool, the appropriate tool to use, and teach you how to use that tool and implement it. I'm not going to teach you how to build tools, which is what coding is, building tools, because chances are somebody's already built that tool. That's the great thing about open systems. So before I talk about Linux and what LAMP stands for, first of all, let me tell you a little bit more about me, as I mentioned, and then we'll get back to what this class really entails. I know I already downloaded the intro for the 4477 class, so I'm just going to go through that. Oh, no, not that one, excuse me. blah, blah, blah. Ignore most of that stuff. Where did it go? That's all right. Let me go log into 4477. 15074. Content. Intro. Just trying to get to this intro thing here. I thought I downloaded it. Intro to the class. I guess I did. Just couldn't find it. I'll tell you what stuff to ignore, what stuff to pay attention to. I'm only showing you the bio parts of this so you kind of know where I'm coming from and what my skill set and my knowledge is and why I developed this class and why I teach it. Give me 1 second. Okay. Okay, so that's the bio about me. Jake at uh.edu. My office is officially 122, the EI lab. Now, normally you guys would have access to the EI lab, which is like a little miniature data center. And I'll show you, I'll make a little video. Not going to do it today, but I'll make a video. Actually, you can see some of it. It's going to look weird with my virtual background. But I'm actually in a little miniature data center here, and there's servers in a rack. And normally I would have you guys access these servers, but because of COVID-19 and because we're not meeting face-to-face, I'm going to have to basically do a lot of this physical layer part for you. And you guys are going to be concentrating mostly on installing virtual machines and installing applications on top of already existing operating system software. So I'm an adjunct professor, not a real professor. Actually, that's not true. I've been teaching for a long time, but I do other stuff. That's the point. I have a business. I have a networking company, a voice over IP telephone company, and a turnkey. I help companies install everything IT-based when they start up, usually small companies, doctors' offices, clinics, lawyers' offices. I've been doing this for a long time, 35 plus years. I have degrees in computer science and business MIS. From here at U of H, Dr. Parks was one of my teachers. I assume everybody in here has had Dr. Parks for at least one class. Yes, sir. Anybody not had Dr. Parks for anything? So he's been teaching for almost as long as Dr. Scammell. Scammell and Parks are probably our two most venerable professors here, and I'm actually off and on since 1995, one of the older ones as well, although I'm only 55. Been teaching a long time as well, because I've been teaching since I was 29. I used to be younger than most of the students here. So since 1995 in the College of Business and also over at the College of Computer Science, I used to teach a programming language called COBOL, which there still is COBOL code out there. As a matter of fact, most recently, the COVID-19 virus, the COVID-19 pandemic has brought COBOL back into the light, and that is because many state governments are still running their Social Security, not their Social Security, their unemployment offices and their state offices on COBOL code, not necessarily mainframe computers, but code that's 35 years old that was never converted into anything else. And the state of New Jersey, for example, recently put out a plea saying, please, if there's any COBOL programmers out there, we need some help fixing this stuff up. So that's what I taught. Started teaching back in '95. I've taught most of the MIS classes here, the systems analysis and design, the intro class that Anisi teaches, Felvegi, and then the Parks' classes, of course. My first computer experience was a Radio Shack TRS-80. Actually, my first computer experience was using some mainframe computers when I was a kid. At my dad's office, he worked for Gulf Oil, which well, it's called Chevron now, downtown. I'm one of the early Linux developers. So I mentioned Linux before, and we're going to need to learn, you are going to need to learn the Linux operating system. You have to prove to me by the end of this class that you are at least proficient in Linux, that I can ask you to do certain things, get a directory listing or copy files or move files around, generally be able to navigate through the Linux operating system, which it's mostly command line, but there also are GUIs, and we will experiment with installing a Linux-based GUI. In fact, if you fall in love with Linux, like a lot of people do, you might decide, well, I've got this old laptop here and it runs like shit with Microsoft Windows on it because, excuse my language, but I use profanity occasionally to make a point on some things. And so if I offend anybody, I apologize. But Microsoft has become, and since they try to become all things to all people, it's become this huge bloated monster of an operating system such that it really slows your computer down. But the nice thing about an open system such as Linux, where you can pick and choose the tools and the pieces that you want to install from the operating system, you can basically make a customized operating system with only the pieces that you want, only the programs installed that you want. For example, like I was installing Windows 10 on a bunch of laptops for students today. And whether you want it or not, they download Windows 10, downloads Candy Crush Saga and the Xbox Companion, and puts a lot of crap in your Windows computer for gaming or for social interaction that you might not necessarily want, but it clutters up your computer. Well, with an open system like Linux, you can pick and choose the things that you want, and it makes for a much more lean, it's like building a car, almost like building a car from the ground up, or choosing your pieces. You get to choose what tires you want, what engine you want, what seats you want, what steering wheel you want. As opposed to just, you can, these days when you buy a car, even if it's a new car, the only options you really have are whether it's leather or cloth, or the very unimportant options, in my opinion. So I'm one of the early Linux OS developers, started back in the late 90s, Linus Torvalds, and you need to know his name, by the way, the father of Linux. Never met him in person, but we've had many telephone conversations. Oh boy, I cannot type today. Linus Torvalds. I guess I should capitalize his name to be respectful. Is the father of Linux. He didn't necessarily completely invent it, just like Mark Zuckerberg didn't invent Facebook, but he's considered the father of it. And also something called network address translation. Both of these pieces of code, the Linux operating system and the network address translation, are extremely ubiquitous, meaning it is everywhere. How many of you have an Android phone? It's in the class right now. I assume a lot of you are Apple people, but some of you are Android people. And I don't claim that one is better than the other. There's pros and cons to them, but Android phones, the OS for Android is Linux based. How many of you have a smart device at home, whether that's an Amazon, one of these Alexas or Echoes, excuse me, or a Ring doorbell, or a smart home device that turns off and on lights, or a smart TV, or a Roku stick, or a, gosh, just tons of things. So both Apple and Microsoft even develop hardware that uses the Linux operating system. In fact, Apple OS looks more like Linux than Windows does. All of these smart TVs, your cars, your smart thermostats, the lights, they are all Linux based. And why are they all Linux based? Because it is open. So that's why you need to learn Linux and the network address translation protocol, which we may not even talk about in this class, but Linux is more important. I help develop methodologies here in the RICS lab that we use today in the College of Business. I own a voice over IP networking cloud computing company. I only have 3 employees. I'm very small, but that's because I'm more of a consultant than anything else. So let's talk about open and what an open systems is. If you were to go Google for open systems, let's just go Google. I use Google a lot, by the way. I'm trying to open another window here. If you were to type in open systems, you might get a few different answers as to what open systems is. You can go to Wikipedia, Open Systems Wiki, see what that is. Let's take a look at the Wikipedia entry for open systems. See what they say. It's one of a class of computers associated software that provides some combination of interoperability, portability, and open software standards. That's the key term there, an open software standard. So what do you guys think that means, by the way, when I say something is open? As opposed to, and I'll give you a hint, as opposed to the Apple OS, which is closed. And the Microsoft OS, which is kind of in between. It's open if you paid for it. Code is available. Be more specific, Robert. People used to think that it meant that the source code was available, which it is, but it's not necessary. You don't need the source code. What it basically means, anybody else want to chime in? Say anything that they think we can change the code on a software. Yes, sort of. Can you say that a little bit better, or anybody else? And you might see the word Unix here, by the way, Unix. So here's the real definition, in my opinion, and there's two real definitions, but here's the main definition of what an open system is when do you pay? That make any sense to you? When do you pay? Might sound a little confusing unless you think about it. When do you pay? What do I mean by that? You never pay. Okay, so you're a Linux expert, Robert. Is that what you're trying to tell me? Well, then you're going to pay. If you're using a Linux operating system or open system software, that is software which is essentially free, and there's a lot of free software out there that you can download. When you download free software, when do you pay? And the answer is not never. Otherwise, companies like Red Hat, by the way, you guys ever heard of Red Hat? Maybe some of you have heard of it. They're a Linux distribution company. IBM bought them. They give away software. It's free. Linux is free. They give it away. IBM paid $34 billion to buy them last year. Why did IBM buy a company that gives something away? You're almost there. Some of you are almost there. Turn on your microphone if you want. Blurt it out if you think you know the answer. I'll give you a few more seconds. And probably some of you understand this already, what I'm getting at. What I'm getting at is the program, whether it's source code downloadable or not. And the original Linux was you downloaded the source code and compiled it yourself. But these days we just download a distribution such as Red Hat or Debian. Pay attention to these terms. Anything I type in a little WordPad document here, you need to copy and paste those things or remember those things and go Google them either now or later on. So you know what these things are. These are all distributions or distribution companies that distribute Linux, the free operating system. They're packagers. What they're doing and what they're hoping is that you will download and use this free tool. Here's a screwdriver, here's a hammer, here's a more complex tool for you to use. You can either learn how to use it on your own, or you can pay us a monthly subscription and we'll teach you how to use it, or we'll support it for you, or we'll let you use it to build other tools with, and you pay us a monthly subscription or a licensing fee in order to use our toolbox to create new tools. So the answer is, with open systems, you pay later. With a closed system like Apple OS or Microsoft, you pay upfront and later. They get you both ways. They get you in and they get you out. You got to pay for the operating system, pay for the tools up front, and then possibly optionally pay for support or pay to upgrade those tools or pay for additional tools later on. Usually the difference with a closed system or a system like a documented or a commercial, sometimes they call it a commercial based system, or sometimes this is called freeware. Although usually freeware refers to one single app or application, whereas a distribution of an open system refers to an entire operating system that controls a computer, that controls a server. Usually when you pay for something up front, you get the owner's manual, you get a certain amount of hand-holding included, or you get a certain amount of warranty included, whereas with Linux, there are no warranties expressed or implied. They're just basically making the tool available for you. You download it, and anything that you create or destroy with it, it's your responsibility. And then when you get yourself in trouble, if you do, then you can come back to us and buy a subscription. So open systems is all about, when do you pay? All of these companies, Red Hat, Debian, CentOS, Ubuntu, and there's many, many more. If you were to just simply Google for Linux distributions, you will see there are dozens and dozens of Linux distributions. Or just Google for the different images of Linux distributions. Every Linux distribution company has some sort of an animal or an icon associated with it. The one I used to work on was called Slackware. Eventually it became Fedora, which eventually became Red Hat, which got bought by IBM. So I said, screw you, I don't like IBM. So now I'm more of a CentOS Debian guy. But whereas in the case of Apple and Microsoft, and I'm just trying to make you guys get your head around what a distribution is and how the Linux operating system is very different, not in its operation. It's actually very similar in its operation. It can do all the same stuff that Apple can do. There's browsers, there's email programs, or if there's not that come with these distributions, there's a bunch of freeware apps or commercial apps sometimes that you can download and you run on top of Linux to give you all those tools, all the different things we need to do, whether that's an email program, a web browser, a chat program, a video editing program, a networking program, some sort of a communication program, anything is available. We give you the base tool set, and you can purchase or download these other tools and install them, and then you pay for support. So the way these distribution companies make their money is through subscription, support subscription. Somebody's got their microphone on and making a lot of noise. By the way, okay. So it's subscription. Subscription based. Now you can pay a certain amount of money for a CD or a DVD, but most of these distributions you can just download them for free. Like one of my favorite distributions is Debian. So if you just type in Debian, or actually not Debian, CentOS. I like CentOS better. Let's go to CentOS. We just go to CentOS. No, not the forums. You go to CentOS.org. There's download links right off that main page. So it's here, download CentOS and start playing with it. All you have to do is sign. You have to sign a little end user license agreement that says, "I promise not to sue you if I end up doing something stupid, like erasing all the data on my computer or causing my mom to get a virus on her computer or whatever it is." These distributions. First of all, let me go back to the distributions. Whereas Windows and Apple have essentially one or maybe a couple or three different distributions, you can buy Windows Pro, Windows Server, Windows Enterprise, those kind of things. With Linux, you have dozens of different distributions because no one organization owns it. Dozens and dozens, and you can download the distribution which most better fits your needs. If you're into CAD design, for example, you're an engineering person or an engineering company, you might want to download a version of Linux that has tools, or a distribution of Linux, excuse me, that has tools in it designed for graphical drawing and graphical design, and support high-end video cards. If you're a voice over IP telephone networking company like me, you're going to download versions and distributions and subversions that have asterisk or free free PBX or Bluehost, or there's different distributions of voice over IP software, different apps for voice over IP that you can download. So there's distributions, and then of course there are apps. Now, normally you guys download apps on your phones through like the Google Play Store or the Windows, I think they still call it the iTunes Store, right? Even though it's not really iTunes anymore. The iPhone Store, whatever they call it. So keep in mind that a distribution is different from an app. We're going to start off with downloading, and I'm going to have to do this for you. Usually I actually have you guys download and install a distribution of Linux on top of a server. Now, if you were to download CentOS or download Debian, you go here and you click on download. What you're downloading is an ISO. Does everybody know what an ISO file is? What is an ISO? An ISO is, excuse me, an ISO is an image of a distribution which is intended to be burned onto a DVD or a CD or put on a USB stick or a thumb drive, inserted into a computer and installed such that it will wipe off whatever's on that computer. So first of all, I want you guys all to understand that I do not want you downloading CentOS or Ubuntu or Debian, burn it onto a CD or a DVD, and then stick it in your laptop and boot off of that, because that will erase everything on your laptop. Now, if you have an old laptop or an old computer, well, you're kind of ahead there, and I highly recommend doing this because it will teach you a little bit better how to use these operating systems. Anybody ever heard of Finally? There's maybe you're up late at night, you watch these infomercials called Finally Fast or Speed Up My PC, or say, do you have an old laptop that's slow? Buy this USB stick, or buy our product, which is basically just a USB stick with a flavor of Linux on it, and they'll sell those for $50, $60, $70, all that they are. And this is, to me, this is crazy. This is literally insidious. They're literally, it's like somebody walking around scooping up nuts off the ground, packaging them, and then selling. Hey, here's a bag of nuts for $10. Yeah, so yeah, you can, if you have an old laptop, you can download a distribution of Linux, whether it's CentOS or Ubuntu or Debian or Mandrake, or there's 100 of them. Put it on a USB stick, boot your laptop off the USB stick. It'll erase everything off the hard drive, install itself. Maybe it's a GUI version, maybe it's not. Usually the useful ones are GUI versions. And they give you all the tools and all the capabilities of something like Linux, Windows, or Apple Mac OS. But it's not, it's something different. It's like driving a different car. It's still a car, it's just a different brand, different model, does things a little bit differently. So if you've got an old laptop, Jessica, or Robert, or anybody that has an old one, I highly recommend, in fact, you will get extra points in my class if you happen to have, and you need to prove this to me, this is an alternative project you can do. Get an old laptop. And a lot of times you can get people to give you, this is where we've gotten to now. I know I have customers all the time that literally give me old laptops, like they're really old, like 10 years old. Like, here's an old Windows XP laptop. It's a piece of crap. It's so slow, blah, 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 whatever. Well, I can take that old laptop. It's 10 years old. As long as it's physically functioning, I'll stick a version of CentOS or Ubuntu on it and basically make a new computer out of it. And it works really well for what we need to mostly use a computer for. What do you guys use your computer for? What do you use your laptop for? You store things on the laptop? You play games on the laptop, or maybe not, but really, where do the apps that you use live? Where does the music that you listen to live? Where are the documents that you're creating? The spreadsheets, where do they live? They live in the cloud most of the time. They might live on some people's hard drive. Robert says hard drive, but if you're like most people, Robert, you're putting your stuff on the Google Cloud or the iPhone, the Apple iCloud, whatever they call it. The iCloud, is that what they call it? Or you're using somebody else's cloud. You're using Dropbox. You're storing this stuff somewhere else. So your device that you're using, your laptop, your cell phone, is just a dumb terminal. It doesn't need to be actually that powerful unless you're playing Fortnite or Counter-Strike Source, or you're playing some high-end game where you need super awesome graphics. Excuse me, due to the nature of my bit, and I needed to mention this earlier, due to the nature of what I do, a lot of times I get text and calls, and I'm on call essentially 24/7, which means occasionally, and this might happen this semester, hopefully not, occasionally I will have to postpone class or not have the class synchronously because I'm in the middle of firefighting or putting out an IT fire or a networking fire. That's why people call me. Sometimes I'm the call of last resort. We can't figure it out, call Jake. Hopefully he can fix it. And not to brag, but if I can't fix it, you're in a lot of trouble. I've been doing this for a long time. So occasionally that will happen where I have to glance at my phone or whatever. I'll try not to do that. That's the good and bad of this class. The bad of this class is that sometimes I'll be a little bit distracted. No, I shouldn't say that. Sometimes I won't have the class synchronously, and that's why it's good that I'm recording all of these and putting them on YouTube. But the good part for you is that I work in the real world. I work in not the academic world, although I am here. I work in the right now what companies are using world. And I'll tell you, many, many companies are using Linux, whether they realize it or not. So I'm going to teach you guys stuff that will make you very valuable. If you put the word Linux on your resume, if you put virtualization technology, if you put open systems, if you put LAMP, the word LAMP, L-A-M-P, if you put that on your resume and you actually know what it is and you can prove that, you will get a good job. You will be hired and be paid more money than the next guy who says, well, I know about spreadsheets, I'm a Microsoft guy. You won't get paid as much. Those are a dime a dozen. The real money and the real need is for people that can basically take a company's infrastructure and migrate it into the cloud. Everybody's rushing as fast as they can to update and migrate their data, which lives in either in their local data centers into somebody else's data center, or give them remote access so that their customers and their employees can access their data from somewhere else. And overwhelmingly, most websites in the world, most data centers in the world, 80% of them or more are running Linux as the back end for their operating systems. Even Microsoft and even Apple, they may not admit it, but I promise you that they are. They're running Linux in the background somewhere. When you're going to Amazon.com, when you go into Facebook.com, Twitter.com, TikTok, whatever the hell that is, that's all Linux based, I promise you. So again, you know Linux, you'll be, so that's the good part. I know a lot about that stuff, and I'm teaching you guys stuff that it's going to make you valuable. It's going to give you better starting pay. It's going to give you some job security, I hope. Don't be a Microsoft and don't be an Apple. Don't have blinders on. Don't have the Microsoft and Apple blinders on. I've got 3 cousins that work for Microsoft, and they have the Microsoft blinders. It's like, oh, everything Microsoft can do everything. Well, no, just like a Cadillac is a good car, but they don't do everything. Cadillac can't haul a trailer, 10,000-pound trailer, very well. It's not designed to do that. Okay, so getting back to this, what an ISO file is that's a downloadable image that you can burn onto a USB stick or one of these things. If you haven't seen one of these in a long time, a CD or a DVD. We don't really use these anymore. We use USB sticks, or we just boot off this ISO image virtually in the cloud, and we install it. Now, what we're going to do in this class is we're going to also learn how to use virtualization technology, or VT, which goes hand in hand with Linux and hand in hand with installing operating systems where you do not install them on bare metal. You create a virtual environment to then install this operating system on top of. So how many people have heard of a product like VirtualBox? Question mark, question. You ever heard of VirtualBox? And I don't know if there's an Apple version of this, but there's definitely a Windows version of this. What VirtualBox does is you download this code. It runs as an application. You install it as an application, and it presents from that application a virtual platform or a virtual environment called a VE, which you can then download and install CentOS into. You create a virtual machine on top of your Windows computer or on top of your Apple computer so that you don't have to blow away whatever OS is on your machine. So you can, in this class, if you already have an old laptop or an old computer, doesn't have to be a laptop, you can install Linux on BM. What do you think BM stands for? And not that. What is bare metal? That's what BM stands for. If I say install something on bare metal, I'm saying take a computer, take a server, take a laptop, and install the operating system on that hardware so the operating system is talking directly to the hardware and has 100% control of it. It can talk to the hard drives directly, the memory directly. It takes whatever was on the hard drive before and blows it away, and it becomes that. That's what those finally fast PC sticks are. See if I can find finally fast. I think that's what it was called, finally fast. Oh, there, the finally fast commercial. So they literally sell this crap for like $80, and it's free. It's free shit that you can download. It's just so funny. All they've done is they've basically, and this is what the distribution companies do. They pick and choose 50 or 60 popular tools, or maybe not even that many, that people use, and they package it all up, and they say, look, here's this thing that you can buy for $80 from us. And it'll look like Windows and pretend to be Windows and maybe even run Windows software. But you could have done it yourself. You could have gone shopping yourself and picked up off the shelf or off the ground the free tools that were there. So whoever invented this concept of making your computer faster is marketing wise pretty freaking smart. So go check out those Finally Fast commercials after you read up a little bit about what Linux is and what distributions are, and then you'll realize, man, this is a pretty good scheme to come up with a version of Linux GUI that looks enough like Windows and gives you what are the popular tools people need? You need a web browser, right? You need an email program, you need a word processor, you need a spreadsheet, and maybe you need a database manager. And that's it. I mean, assuming that you're not using your computer for gaming. That's what your Xbox is for, okay? Or your PlayStation. But the 5 things that you do 99% of the time on your computer is you surf the net, you write letters, you mess with spreadsheets, and you maybe create a database. That's it. That's 5 basic apps. And then there's a bunch of little ancillary apps that go along with that. Excuse me. Doesn't really matter to me or to a lot of people. Like when you need to go drive somewhere, when you need to rent a car, does it really matter to you whether it's a Hyundai or a Kia or a Cadillac, maybe if you spend extra money for it, but does it really matter if you're on vacation or whatever and you just need to get from your hotel to Disney World, 5 miles down the road or whatever it is? Do you really care what kind of car it is? No. As long as it's a car, as long as it's got 4 wheels and it's reliable, it's got a steering wheel, doesn't matter what it is, as long as it does the job. So anyway, getting back to this Linux on bare metal. If you have an old computer, you can download one of those distributions, put it on a USB thumb drive, which by the way, I carry a thumb drive around on my keychain all the time, 1 or 2 all the time, because you never know when you need to install an emergency version of Linux. Or you can download a distribution, a VE distribution, or we call it distro for short. Oops, there goes my light. Ooh. You guys like my background? That's one of those 4 virtual backgrounds. I guess I need to download a Cougar background like Dean Pavlou and use that one instead. A VE distro, a virtual environment. So let's say that you want to build not a workstation, but you want to build a server, which is what we're going to do in this class. We want to provide services to our employees, to our organization, to perform certain tasks, whether that be a database management service or a communication service such as voice over IP networking, or providing a platform to put virtual workstations on that somebody can remotely log into and use across the cloud. So for those of you that have an Apple, you can use something like TeamViewer or Chrome Remote Desktop or VNC or any of these other, or GoToMyPC, and remotely view a Windows computer to run Windows 10 apps because maybe that's what your company has decided to standardize on. Excuse me. There is something to be said for standardization, and a lot of companies choose to standardize on a particular operating system because it's easier to teach that. If you have to support many different operating systems or many different distributions, it makes your IT department, it dilutes their ability to do that because everybody's driving a different car basically. Even though the general pieces of a car are there, a Fiat has things in a different place than a Ford. So distributions, example of some distributions would be like, and I know some of you have heard of some of these, like VMware. What do you think the VM stands for? Virtual machine, VMware. So I want you to go get familiar with, this is what your homework is for tomorrow. Yes, I'm not going to grade it, but you need to do this so that we can start having conversations. Your homework is to go look up what VMware is and why we would use VMware. It's designed to install onto bare metal, but you install it on a server, which usually sits in a data center, not a workstation. Servers typically have to have a lot more memory, a lot more hard drive space, a lot faster internet connectivity, because we're installing this virtual environment to run multiple workstations or multiple other servers on top of, multiple web servers, multiple email servers, multiple gaming servers even. So VMware is a type of virtual environment OS. It happens to be based on another open source distribution called BSD, which is basically just another version of Linux. And I haven't really talked much about what Linux is. I'll talk a little bit more about what Linux is and where it came from. I have a PowerPoint for that, so we'll look at that in a minute. I'm trying to give you guys a lot of things to look at for tomorrow. There's also KVM. Kernel-based virtual machine. It's a Linux product, very much like VMware. You download and install that on bare metal, and you can fire up virtual workstations. They can be Linux workstations, they can be Windows workstations. I have virtual servers running that have 36 Windows workstations on them. You might be wondering, well, why do you have 36 Windows workstations? Well, I provide them to my clients so they can log in and have a Windows 10 session. We do that for the students, as a matter of fact. Normally, I provide through VMware, everybody's going to get access to, and I have to figure out how I'm going to do that this semester. Still haven't quite figured it out. But everybody's going to get access to a Windows 10 workstation, not a server. You're going to do servers too, but we're going to give you access to a Windows 10 workstation. It's actually a virtual workstation, but you have admin rights on it. Meaning you will be able to install software, make changes to the IP address, and change things on the workstation that you normally would not be allowed or able to change on a lab computer. How many of you have used lab computers here at U of H to do something with? They're relatively locked down. You can't install additional software. They just basically provide those tools for you. Am I right? Oh, is that correct? I think they provide a browser and maybe the statistical software that you use in the stats classes, but you can't install additional software on them. Well, I want you guys to be able to install software and experiment with things, find the best tools for things. But the only way we can do that is we give you a virtual Windows environment. Just like playing a virtual game like Fortnite or Grand Theft Auto. That's a virtual environment. Why do you guys play Fortnite or Grand Theft Auto? I assume everybody in here plays something. Or Candy Crush Saga or whatever. Why do you guys play those games? Anybody in here play Grand Theft Auto? Yeah, it's fun. It's because you can do stuff in those games to waste time. There's a lot of other stuff you can do to waste time too. We play those games because we can do stuff in those games that we can't do in real life without being murdered or thrown in jail. You can't run over prostitutes in real life. Apparently that's not allowed. You can't shoot people and kill them in real life. It's, you go to jail for that. You can't look like an eagle and float down on a balloon in a bus with a balloon on the top of it, because it's just, it's entertainment. In other words, in a virtual environment, which is what those things are, those first-person shooters, those games that we play, they're providing a virtual environment for us to play in, so we don't fuck up the real world, so we don't kill ourselves or do things that is not appropriate to do in real life, IRL. So we have the virtual world, and then we have the IRL world, in real life. You guys ever heard that term, IRL? Oops, didn't mean to type that there. So IRL just means in real life. So let me just ask you guys, this is an opinion. Do you believe that you, or if you have kids, do you believe our kids are becoming desensitized to violence because they're playing Grand Theft Auto or Fortnite or even Minecraft, or games where they're shooting people or killing people, or the object is to have the most kills. You do think that? What if I argued with you, and I'm not saying that this is right, but humans have a tendency to be violent. What if I had a violent streak and I needed to take out my violence, or I needed to take out aggression in some way without actually killing people, without actually doing bad things that send me to jail? If I can play a video game, or I can immerse myself in a virtual environment to release those aggressions, I think that's a better thing. And that's my opinion of it. I was a fairly violent kid. Not love to, but I picked fights a lot and got into fights because I didn't like, people, oh, you're short, or you're skinny, or you're ugly, or whatever. I don't like you. I get in fights a lot. But in a virtual world, you can pretend to be stuff that you're not. You can, be good at stuff. But I like to shoot things, but I don't like to shoot things in the real world. It's fun to do that. I play Counter-Strike Source a lot. I haven't played it in a while because I've been doing this. My point of all of this is that a virtual environment lets you try stuff out and do things that if you did it in real life, you might make a mistake, or you might kill a computer, or you might kill data, or you might damage something either logically or physically. So virtual environments are used, and they're very good for prototyping, testing, experimentation, doing things that you normally can't do. I don't expect you guys, you can do this if you want, but I don't expect you guys to have access and find an old laptop laying around. I mean, it's fairly easy to do. You can usually convince some friends or your parents, hey, you have an old laptop in a closet somewhere I can have? Like, sure, I was going to give it away. Here, you can have it. Not that difficult, but I don't expect you guys to do that yet. But if I give you a virtual Windows 10 machine that you can install code on and experiment with, and you screw something up, all I got to do is push a button and roll it back and give it to you again. So you can do almost, not quite. You can't physically put your hands on the actual machine, but you don't need to. You're putting your hands on your own machine and you're virtually viewing another machine. You can do almost everything that you need to do in terms of experiments. So I'm going to assign everybody a Windows 10 virtual machine, and then you're going to use either Chrome Remote Desktop or TeamViewer. I haven't figured out exactly, again, how to do that. In this class, on the server side of it, not the Windows workstation side of it, but on the server side of it, we are going to install a product called Proxmox. It's not as popular as VMware. VMware is probably the most popular. Oh, and Microsoft, of course, they have their version of it. What's Microsoft's virtual environment called? Anybody know? Hyper-V. It's called Hyper-V. So Microsoft Hyper-V. It looks like Windows. It smells and tastes like Windows, but it's a very bloated version of a virtual environment that you can then install other Windows servers or workstations on top of and let people remotely log into it. So that's Microsoft's version of a VE. So make sure you understand a VE stands for, what's VE stand for? Virtual environment. So you need to learn these terms. If I say VE, what am I talking about? A virtual environment, which is two things. It's a piece of hardware, usually a very powerful piece of hardware, more so than your laptop or your desktop computer, running an OS that can present itself as a platform for other virtual machines, or VM, to run on. So VM stands for, excuse me, guess somebody's at my front door. Sorry about that. I should have put my phone on vibrate. VM stands for virtual machine. So VE is the environment, virtual machine runs on top of a VE. We're going to install and use Proxmox. It's my favorite one. Now, I used to have this class install, actually download and create the USB stick and go through the process of actually installing the Proxmox. I don't know if we want to or even need to do that anymore, because I think a lot of people get bogged down on the technical part of that. And frankly, these days, when you go and you, because a lot of companies and even individuals do this. This is like what Mark Zuckerberg did when he was first starting Facebook. He didn't have the money to go out and buy a bunch of servers, and buy a data center. He started in his college dorm. He rented a virtual machine or a virtual environment. He rented a piece of a computer in the cloud and installed software that he wrote and other people wrote on top of that and experimented with that. Paid a monthly subscription fee. You don't have to install this kind of stuff. You can rent an instance, we call it an instance, of either a Windows server, a Linux server, an email server, or a Windows workstation. You rent an instance of it, you pay $5 a month, for example. It's kind of like Office 365. How many people are using Office 365? You guys all get it for free being a U of H student, right? What's the difference between Office and Office 365? Other than the numbers 3 and 6 and 5 after the word Office. What's the difference? Yeah, it's subscription based. In other words, Office is an application that you purchase and download or buy on a DVD and install on top of either Windows or Mac OS. And it has to live on your computer, takes up space on your hard drive. Things that you write go onto your hard drive. You can optionally upload them to Dropbox. Or you can subscribe to Office 365 and use a virtual version of a a virtual version of a word processor or an Excel spreadsheet. Google Office is their version of Office 365. What we're using is simply a web browser to give us a window to that tool that looks like a word processor, looks like a spreadsheet, looks like a database program, looks like a place to drop files. So we don't have to do this, but I'm going to probably do that part for you, and then I'm going to rent you or give each member of the class, I'll give you a Windows 10 workstation to work on, and then I'm going to give you access to a Proxmox server. Now, Proxmox is a virtual environment, which is actually a combination. Proxmox is two products. And again, this is part of your homework. You need to go look up VMware, so you know what VMware is. Go look up Hyper-V, just so that you know what all of those are. So VMware, Hyper-V, and Proxmox. Those are the three most popular ones in the world. There are some others. There's Citrix, and Oracle has theirs, and IBM has theirs. I don't know what it's called. IBM's still a company. Those are the three most popular ones. Proxmox I like because one, it's Linux based. That one's micro crack based, and that one is BSD based. And I'm a Linux guy, but it includes actually two technologies. Proxmox is a combination of something called KVM and another thing called containers. So a KVM, or a kernel virtual machine, is basically that's where you first install Proxmox onto bare metal, then you download an ISO of Windows or a Linux distribution or FreeBSD or something that's an operating system, and you run it as a virtual machine, and you carve out 4 gigs of RAM, for example, and here's 30 gigs of a virtual hard drive space, which is going to come off your local hard drive. And here's your network card, your virtual network card. And you're going to run essentially as a standalone computer. It's not really standalone, it's a virtual computer. Whereas a container, and this is what I want you guys to try to understand in the beginning here, before we even start talking a lot about Linux. In fact, I think what I'm going to do is not even talk that much about Linux today. I'll talk more about Linux, and I'll get into the PowerPoint of what Linux is in the next class. I'm going to cut this class a little bit short because I want you guys to fully understand what virtualization in a virtual environment is and what a KVM versus a container is. So if we click on Proxmox VE, that company, by the way, makes 2 different things. They make a mail gateway and a virtualization platform. Proxmox VE is a complete open source platform. In other words, when do you pay? You pay later. For all-inclusive enterprise virtualization that tightly integrates the KVM hypervisor. And by the way, that term right there, hypervisor, that is the generic term. That's like saying car. Instead of saying Cadillac or Volkswagen, I need to go drive a car. Hypervisor is that generic term. Hyper-V is a hypervisor. VMware is a hypervisor. KVM and LXC are all hypervisors. Proxmox uses 2 of those technologies which I just mentioned. One of them being KVM, which was written by Linux people, and then another one called LXC, which is also written by Linux people. KVM runs a completely standalone instance of an operating system that does things independently of the underlying virtual environment, whereas a container, an LXC container, is an instance of the underlying operating system. So the underlying operating system of Proxmox, the operating system of choice, is Linux. If I wanted to create additional Linux virtual machines to experiment with, I could create containers with Proxmox. It's basically an instance of the underlying operating system. It relies on code that's already been installed when you install Proxmox. In other words, if I fire up a container, I say, here, I want to build a container, give it 1 gig of RAM and 20 gigs of hard drive space, and I want it to be CentOS based. It'll fire up a container for you. There's very little that you actually have to download. It's a template that you download. And then if you run a program in the container, it's actually running a program that's been installed by Proxmox already. So if you're running a word processing program, it's running something that was installed under Proxmox, a word processing program. Whereas in a KVM environment, it's just like you booted up a fresh new computer with no OS on it, and you have to install everything. Once you've installed your Windows OS, for example, then if you wanted to install Microsoft Office on top of that, you could. If you want to install Google Chrome for a browser on top of that, you could install that. But it's not a requirement of the underlying virtual environment to have that code installed. It writes that code into the hard drive somewhere, but it's for the exclusive use of just that virtual machine. Okay, so that's an example of what the front end, and I can show you an example of Proxmox, but I'll just show you some screen prints of Proxmox. So we build a Proxmox virtual environment, and then we put virtual machines on top of it. I'm trying to get through this to get to some examples of some virtual machines that are running. This is an actual how-to to install containers and virtual machines and storage. And we're going to do this. We're going to install I'm going to install the Proxmox for you, but then I'm going to want you to choose a distribution of Linux, whether it's Debian or CentOS or Ubuntu. I don't care. I recommend one of those three, to create a virtual machine, one or more virtual machines, so that you can start experimenting with and learning the Linux command line, what's called CLI, command line input. And eventually we will install a Linux GUI, just so that you can go, oh, hey, that's kind of like, that looks like Windows. It's a car of a different brand. Linux, excuse me, I typed that wrong. And I'm going to also have you guys, I'll provide the distribution for this. I'm going to have you guys also install a Windows 7 or 10 workstation on top of the Proxmox, so that you can go, oh, hey, I installed Windows, and I've got admin rights to it. So we're going to have a lot of fun in this class, I think, even though we don't get to physically be with each other. I am going to break the class up into teams, and you guys are going to work closely with each other, although the grade is going to be based mostly on your individual work. I want people to work in teams so that, one, you can help each other out. And also I have in the lab here 6 virtual environment servers. And there's 20-something people in class. So there will be 3 or 4 people per team, and you're assigned one of those 6 servers that you will have admin rights to, and you can log in and build your own virtual machines. Of course, you're going to need to coordinate with each other, because you don't want to step on top of somebody else's toes. You're going to be setting up, in the case of servers, you're going to be having to use unique IP addresses. And if you don't know, if you didn't take my 4477 class, I'm going to have to teach you a little bit of networking to get that far. So again, your homework for tonight, before tomorrow's class, so that's why I'm ending the class a little bit early, is to go read up on and give yourself a little bit of background knowledge as to what a hypervisor is, and you can go Google for those 3 products. VMware, maybe you stick the word Microsoft in front of that. Hyper-V and Proxmox. You don't have to download them if you don't want to. And actually, there is one other, by the way, and I mentioned it earlier, VirtualBox, another very popular one. Now, what sets VirtualBox different and what sets it apart is it's not really designed for a corporate multi-user environment. What VirtualBox is designed for, if we go Google for VirtualBox, it's designed to create a virtual world or a virtual sandbox for you to play in on top of your existing laptop or your existing Apple. I'm pretty sure there's an Apple version of it. Let's go click on VirtualBox downloads. Well, maybe there isn't. Maybe there is not a Apple version of it. You guys can go, you Apple people can go check that out for me. Do you need to purchase any books for this class? That's a very good question. Thank you for asking me that, Jessica. I do not have a textbook per se for this class, and that's partly because I kind of invented and developed this class. I haven't written a textbook yet. But most of what we do in this class, this is a research and experimentation class. We do things differently every semester, and not everybody's going to come up with the right answer or the same answer. Maybe you're going to come up with a better version of doing something that we didn't do before. Having said that, if you really feel like you need to buy a book for the class, or you like having a book, I highly recommend the RTFM. The RTFM guide. You can go buy it, or you can just download the PDF of it. The Red Team Field Manual. It is basically, it's not really a textbook. It's basically a reference guide for the Linux operating system. In other words, all the commands that come with the Linux kernel from A to Z. And it teaches you, helps you understand the syntax of how Linux is organized in terms of its file structure, which we're going to start on in next class. So tomorrow, I'm going to run through the PowerPoint on the introduction to the Linux operating system and begin to teach you some of those things. How Linux is structured, how it writes information to the storage, to the hard drive, how you navigate through Linux and its file structure. And it's similar to DOS. If you guys have any experience with good old DOS, or doing things via the command line. Has anybody ever had to use the command line or PowerShell? Command prompt. Some occasionally, where did it go? Oh, it's on my other screen. Let me drag it over here. Occasionally you are asked when you're doing troubleshooting to open a command line and type in some series of commands. Dir, for example, is one. Get a directory listing. CD space C:\\/ to change directories. Dir again. Copy some file to another file. This is called, what that environment is called a CLI, command line input. Back in the old days, Windows was not an operating system. Windows was an application that you downloaded and installed on top of this. This was your operating system. You booted up MS-DOS, Microsoft DOS, and it stopped there with a blinking cursor. So, okay, what do you want to do now? If you wanted to run Windows, you literally typed in windows.exe. You executed the Windows 1.0 or 2.0 GUI application so that you could do GUI things, move a mouse around, type letters, or whatever. So Microsoft and all computers started out with that. 24 lines down by 80 columns wide, what we call a 24 by 80 command line. That's called a command line input. Containers and Linux start out as this, and then a GUI environment sits on top of it. So I'm going to teach you guys. You need to be proficient at this on navigating through CD program. Navigating through Linux. Oh, see, I used the Linux version of that. So again, if you've ever done any sort of navigation through DOS, the disk operating system, or the command line, or PowerShell, that might be a little helpful to you. But that's what we'll start on tomorrow with the PowerPoint presentation, the introduction to Linux. So like I said, your homework is reading up on what those hypervisors are, reading up on Proxmox, and you can go ahead and Google for it to give you an idea of what is Linux, to start to give you a background of what Linux is. There's lots of videos and lots of description, and you go to linux.com. That's probably the best place to go to learn what Linux is, and I'll go through it tomorrow. Okay, so are there any questions? Thanks for mentioning that, Jessica, about a book. Are there any questions for today's session on what you should be doing between now and tomorrow? No questions? I'll give you a minute to say something. No questions from you? Okay. Okay, so I'll say this as a final note for this class for this semester. This is the first time I've taught this class 100% online. So we're going to change a few things. There are previous notes I've already posted on Blackboard from the previous semester, which of course won't apply this semester because, like I said, I'm going to have to do a lot of the physical layer setup to begin with, then hand it off to you virtually because you can't come to the EI lab. You're not allowed to. Only reason I'm here is because I got special permission. I had to beg and plead and say, well, I've got to have access to the servers so that I can, this is a research class. And so I filled out the form, and it helps that when our new dean, when Dean Pavlu showed up, I grabbed him and made sure that he knew that I was the cool guy. in the Bauer College of Business. Whether that's true or not, I don't know. But I needed to let him know, and that's what that was Dr. Parks' suggestion. He says, make sure that he knows you, so that you're not just the low. Who is that guy? There's some guy who lives in the dungeon down there in the EI lab. We don't know what he does. So, if there's not any other questions, I will end this meeting. I'll upload this to YouTube, although it's not going to be probably till much later tonight. So if you do know other people in the class and they're waiting for the YouTube video, it's not going to be probably till tomorrow morning because I've got some other stuff I've got to finish up. Tonight, I'm helping to open, not my business, but I'm helping to open up a COVID-19 testing lab, which is supposed to be up and running by Monday. So I'm helping him install all the networking infrastructure and the Wi-Fi, and he's presenting challenges that I've not had to deal with before, like HIPAA compliancy and maintaining, the social distancing, all the stuff that we're having to do, put up plexiglass and things like that. I'm helping with all of that stuff. So I'll see you guys tomorrow. Thanks for participating. And let's make this as fun and as good as and engaging the semester as we can. I don't want to be the only guy talking all the time. I prefer to see, like I said earlier, I prefer to see some video of some other people. Nobody else has their video on right now, or their audio. My girlfriend teaches elementary school. All of the students turn their video on because they like to be seen, I guess. But I want to see you guys. It helps me to teach the class better. Okay, so I'll see you guys later. Thanks a lot. Go Cougs.